Hey there, sixth graders. We are going to take skills that we already have and combine them all to apply graphing to real world situations, because believe it or not, we actually take a ton of real world situations and we express them graphically, because using graphs we can then determine bigger pieces of information, and it's a good visual for people to understand and learn from. So we're going to work on writing equations, which is a skill you already have from last unit, and then graphing those equations, which is what we just developed. So we're taking these two skills we already have. So really, I'm just going to be going through examples with you and pointing out some things to just be mindful of. So remember, we're going to use our math translation skills. It's kind of like when you're in French class and Spanish class, and you translate sentences. We're going to do the same thing with math, and we are going to write equations to represent real world situations. So the first thing we want to do is identify the unknown, assign the unknown a variable with a let statement. Okay. Look for your key math words and phrases. I suggest underlining or circling some of those key words and phrases that indicate what operations. Now notice how I say plural operations are being used, because I'm probably going to give you two-step equations. One step is too easy at this point, but who knows, maybe I'll be nice. And the last step is you write your equation, but please write down, make sure that something is happening to the variable. Do not have it be x equals 2 times 5. That is not an equation. What we would need to do is say that, whoops. One second. What we would have to say is something like x divided by 2 equals 5. So make sure your variable is not alone. Once you've written your equation, set up a function table, fill out all of the information with the given inputs, and figure out your outputs, and then graph. So let's do some examples, because I think that'll make the most sense. So tickets to the museum are $15 per ticket. Mary has a coupon for $5 off. I'm going to underline that because off is usually subtraction. Per is multiplying. Okay, write an equation to express the total cost y for X amount of tickets. So I'm not saying specifically for 10 tickets or 5 tickets. I'm saying in general, what would the cost be for any amount of tickets? So let's go ahead. So here's what we're going to do. Let's do our let statement down here. Sorry, I didn't give you more room up top, but we're going to say let X equal the number of tickets. So what's happening to the tickets? Well, if we go back up here, the tickets are here, and we're going to pay $15 per ticket. So it's going to be 15 times the amount of tickets we buy, and it's going to be $5 off. Now, I'm not saying what the total cost is. We're going to let that be equal to y, but that will equal your total cost y. So my function is going to be 15x minus 5. So I'm going to write that here, 15x minus 5. So if you buy one ticket, this would be 15 times 1, because remember, this is tickets, and this is your cost, minus 5, that would be $10. So the first thing we'll plot is 1 comma 10. If you bought 2 tickets, you'd be spending $30, but get $5 off, and that's 25 bucks. 2 comma 25. If you bought 3 tickets, that's $45 minus 5 is 40 bucks. And if you bought 4 tickets, that's 60 minus 5 is 55 bucks. 4 comma 55. Okay. We now have our ordered pairs, so we now can graph the function. Okay, wow, I have to get all the way up to 55, which is pretty big. Let's see, let me skip count by fives. 5, 10, 15, 20, 25, 30, 35, 40, 45. That's not big enough, so let's skip count by tens. So 10, 20, 30, 40, 50, 60, 70, 80, 90. And I'm going from 1 to 4, so I'm going to go ahead and skip count by halves, because that would be 1/2, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, just to keep it spaced out and nice and neat. All right, and now let's graph those ordered pairs. So 1, 10, 2, 25, 25 is halfway between 20 and 30, 3, 40, 4, 55. And it turns out if you bought 5 tickets, you would have spent $70. So let's go ahead and connect that with a straight edge. I don't have one at hand, so I'm going to use a pencil box. And all right, there we go. And we have y equals 15x minus 5. So we have graphed our function. Let's go ahead and do a couple more examples together. Okay. Kelsey is flying her plane at 100 feet. The plane can ascend, let's go up, descend is go down, ascend is go up, at 50 feet per minute, per times. Write an equation to express the elevation of the plane y after X amount of minutes. Okay, so we're starting at 100 feet, and then each minute we are ascending at 50 feet per minute. So as time goes by, we're ascending up. So it says, write the elevation, which will be y, after X amount of minutes. So again, I don't know how many minutes in particular, so we're going to keep it super vague, and we're just going to leave it as in terms of X. So let X equal the number of minutes. So we're starting at 100 feet, and if we're ascending, we're going up. So it's going to be 100 plus, because we're going up, 50 feet per minute. Remember, minutes are X, so it's going to be 50 times X. And that's going to give you the elevation, which is Y. That's going to give you the elevation. Okay? So let's use this information, fill out a function table, and graph. So we have the function 100 plus 50x. So this is 100. So after 1 minute, we are going to be 150 feet up. After 2 minutes, 50 times 2 is 100 plus 100 is 200. You are going to be 200 feet up. After 3 minutes, 150 plus 100 is 250. And after 4 minutes, that is at 300 feet, 4, 300. Okay, these are really big numbers, so I'm going to have to be super careful with what I skip count by. We always start at 0. So my y has to get all the way up to 300. So I might want to skip count by 50s. Let's say 50, 100, 150, 200, 250, 300. Perfect. So I'm going to skip count by 50s. And finish labeling your scale, please. Don't just stop halfway. And we're doing 1, 2, 3, and 4. So I'm going to space them out again because I think it's a lot neater. And graph the ordered pairs. 0, 150, 2, 200, 3, 250. Okay, using your straight edge. And label. Y equals 100 plus 50x. All right, let's do one last example, and then I'm going to let you do some on your own. So again, let me just recap. Sorry. so you're using your translation skills to create the equation. Then you are creating your function table to get your ordered pairs, which you then will graph. All right, last one together. James has $150 in the bank. In general, James spends $20 per week, spends, that's usually, spending money means you're losing it, minus $20 per week on his groceries. Write an equation that represents the amount of money James has, Y, after X amount of weeks. So basically I'm giving you the let statement, by the way. So let X equal the number of weeks that might be going by. And here's what's happening. Well, he started with $150 and each week he's spending, so that's minus $20 times the amount of weeks. $20 times the number of weeks. And that will give us Y, which is going to be the amount of money James has, equals Y. So that's what we're going to use as our equation, 150 minus 2x. So let's plug this in. Let's see, after 1 week, if he starts with 150 and spends $20 for the week, that's now 150 minus 20 times 1, which is 130. Two weeks, that's going to be 150 minus 20 times 2, that's 40, so that's 110. 150 minus 60 is 90. So as you can see, his money, his total amount of money is decreasing because he keeps spending money for a lot of weeks in a row. 150 minus 20 times 4, that's minus 80, so that'll be 70. All right, so the biggest Y value I need to graph is 130. Sorry, I kind of messed up on that. That's 130. So I need to be careful about what I skip count by. I think I might try 20s. Let's see. I don't know if that'll get me high enough. Let's see. Oh yeah, it will, because there's 9 boxes that'll get me up to 180. So 0, 20, 40, 60, 80, 100, 120, 140, 160, 180. That got me past the 130. And it's 1 through 4 again, so I'm going to have them nice and spaced out. Alrighty, so let's go ahead and graph. So we have 1, 130, so that's between 120 and 140. And he started out, by the way, 0 weeks, he had 150, so we can go ahead and plot that. Oh, shoot. Forgot to mention, you need to label. You should be labeling what's happening. Sorry, so this is the number of weeks. This is the money. Okay, here we go. 2 weeks is going to be 110. 3 weeks was 90. 4 weeks was 70. And if we kept going, after 5 weeks, he'd be down to $50. Using your straight edge, I'm using a box of pencils. I'm going to connect the dots. As you can see, his money is decreasing, which is fine. It's decreasing because he's spending money. And we label our line. So sorry for mentioning that. I definitely want you to put your units. I apologize, I missed that. But in general, write the equation, plug it in. Using these, figure out your outputs. That gives you your ordered pairs. Then graph your ordered pairs, and please label your units. So go ahead and try your homework on your own.